I learned Rust because I was sick of things breaking. I was sick of
Mhm.
software being unreliable. It just feels very empowering knowing that you can't make a mistake. I can drive my car faster because I know that I can't hurt myself. It doesn't mean that you need to completely shift tomorrow. Instead, I recommend that people gain some experience and learn a little bit about the ecosystem and whether or not it works for them, and try to make sure that the knowledge is spread through the company. Because as soon as you lose that one or two experienced people, the whole Rust project will fail. Rust will not be adopted for another 10 years in your company.
Hello, everyone. I'm Marco de Witte. I'm founder of MainMatter. We're a web development consultancy. We build web apps and cloud apps for international clients. And we also do lots of mentoring and helping teams adopt new technologies. And last year, we made a strategic bet on Rust with a goal to support more teams adopting Rust and benefiting from it in their web cloud projects. Today, I'm talking to Tim McNamara, author of Rust in Action and founder of Accelerant, a new Rust consultancy. Hi, Tim.
Hi, thank you so much for having me, Marco.
Yeah, thanks for coming. Let's start with you introducing yourself a bit more.
So I am a different part of the world than you guys over in Germany. I am currently based in New Zealand.
Yeah, thanks for joining me so late.
That's okay. I mean, one of the things when you work remotely, you start to learn about different call times. I think the hard
Mhm.
thing is actually my kids, because it's easier to have calls later because if they take a while to get to sleep. But
I know you.
my own story is that until very recently, until the end of April, I was working at AWS as the global lead for Rust education across the company. So my job was to advocate for and to support teams who were interested in Rust. And that was extremely interesting because Rust is even though it's very, AWS is a very proud sponsor of the foundation, every team chooses its own technology stack. And the very large incumbent is Java. And there's a lot of Python in there as well. And there are many, many thousands of teams. And that was a really wonderful experience. And unfortunately, the tolerance, or at least the appetite for having people based on the wrong side of the world, very rapidly decreased for AWS this year. And so my role was actually eliminated as part of a global layoff round. And so I thought, why don't I do that? Why don't I do the same thing for everybody? I'm very, and so that's what I've tried to do. A slightly different than your area of expertise. So Matters obviously has a very strong web focus, and I think
Yeah.
that's a very important focus. And I am so excited for one of your previous speakers in this series, Luca, has just started. I'm sure he's going to do amazingly well. My background is actually in data science. So I was in machine learning and natural language processing, and primarily in Python. And so I've worked in a couple of startups to build companies as well as larger enterprises as well. So I guess AWS is the largest one, but also I worked for Canonical, the company that built Ubuntu. And I was working on quite a large system for orchestrating clouds. Canonical does a lot of work trying to make Ubuntu able to be downloaded in multiple different clouds, and so essentially it predated Terraform by a couple of years, but they have a sort of a Terraform-like system that I implemented, or I was part of the team implementing as well. So yeah, my history has been, or my personal professional background has been, I learned Rust because I was sick of things breaking. I was sick of
Mhm.
software being unreliable. I was sick of software being hard to upgrade, or everything had the wrong versions, or suddenly, I've got the wrong version of Python. I got all the dependencies are out of date. These sorts of issues were really big problems. And the other thing that, from a personal point of view, was I really wanted to start to learn how computers actually worked. Rust taught me what a pointer was. Like the Rust community is quite welcoming and very inclusive of people who don't have a systems programming background or a traditional heavy engineering background. And so that was really important to me when I was starting, because I did not have the confidence that someone whose whole career was in C++.
Mhm.
And that was actually why I wrote my book. So my book, Rust in Action, it's sort of two books in one. One, its primary focus is to teach you Rust, but it does that through quite a strange route. Like, it teaches you Rust by giving you examples from systems programming. So, for example, we create a CPU emulator, we create a database, we do all of these really serious, geeky topics that people who have only used TypeScript or only used Python or only used even Java have never really had experience with. But when you start with Rust, you become introduced to lots of language and lots of prior knowledge that is assumed about your background. So people expect that you know what a reference is, and they expect that you know other parts of the terminology that come from C++ primarily. And so I am trying to give you the extra knowledge, as well as the syntax of the language specifically, just kind of the wider environment that you will find yourself in.
I think that's a very interesting topic, in particular also like related to sort of the focus that we have, right? Trying to get people building web backends in Rust, right? Because those are people that come from like Node and like JavaScript, TypeScript, or Python or Ruby maybe or so, which is like obviously completely different from Rust, right? So what's your experience? Like, how hard is it for those people to actually learn Rust and get started? And like, I guess your book helps with that, right? And it's maybe not so hard after all, right?
I think that Rust does have a reputation for being difficult to learn.
Yeah.
What I think, and I think that is very important to acknowledge, that there are some people who find it very difficult. However, the general statement, Rust is hard to learn, I think is false. What I think is more accurate is to say that we, as people learning things, have our own prior knowledge, and then we have our expectations for how programs say, we've learned to write software. No one learns Rust as their first programming language. It's not mature enough. And so everyone has their prior knowledge, but Rust is more strict than other languages. Otherwise, if you program in Rust, there are no null pointers. There are no null pointer exceptions. You cannot have, for example, in Python, you would have an attribute error. If you attempt to go and access a field inside a class that doesn't exist, the interpreter will throw an exception. Now, Rust will not allow that program to even start running because it's much stricter. It's much more bureaucratic. It's much more pedantic. And that mentality that you need to be accurate, that you need to be more precise, is, I think, the difficult thing. Because every single time that you share data in two parts of the program, you need to think about how data is actually going to be managed. And in particular, which part of the program, over here or over here, has the responsibility for deleting that data. Rust does not have a garbage collector. What this means, unlike, say, a Node, if you have a request in Node and it's extremely quick, that's good. And you get the Node receives another request. what might happen is that a part of the node, what we call the runtime, might decide to keep some of the objects that were created in their first request essentially alive, just dormant in memory, until such a time that there is a space where a pause would not affect the user, if that makes sense. And so we might wait, there might be a big spike in usage, and then your memory will increase because your system is under very heavy load. And then when your load goes down, suddenly the memory also goes down very rapidly. And that's because what we call the garbage collector, or essentially it comes along and says, okay, I now have time to operate. All of these objects are available to be sent back to the operating system, and the memory is now free. Piece of the program running alongside your system does not exist in Rust. Instead, Rust will always determine exactly how long every variable lives. So one of the things that is difficult about Rust, every variable has a data type, just like, let's say, Java or Ruby, like pretty much every programming language except for assembly. In assembly, you have there are two types of the data. There's a memory address, or you have numbers. Anyway, all high-level languages use some form of what we call a data type, or we associate a type with zeros and ones. But Rust adds something. It adds a lifetime. That is, it provides this extra bit of information, and that extra bit of information for every variable allows the compiler to actually verify at compile time that accessing memory in different places, or every time you attempt to access a variable, that the data will actually be valid. So there is extra complexity involved in learning Rust because of these problems related to Rust is more strict. Rust will refuse to compile many programs that other languages happily run. So there is increased frustration. And there's also extra work to do in terms of developing a new mental model about how your program needs to run, because every variable has an extra piece of information. That's a long way to answer the question, but I think that it is important to acknowledge that Rust is very difficult for some people, but I think that it is learnable, and I think that it's a very important step forward for the industry, which has essentially no other tool. There is no other programming languages. There was no other programming language that provides what Rust provides, and that is complete speed and complete memory safety.
Yeah. What I found interesting was, I think Google just sort of posted that blog post, right, where they said the idea that Rust is so hard to learn, and sort of you would have like you would pay a price in terms of productivity while sort of adopting it. Like they couldn't prove that sort of with the data they got from 1,000 developers, I think, right? Including people that came from, like, not from C or C++, where you're sort of dealing with similar concepts like memory management and so on, which you have to learn maybe when you come from like Python or so, right? And they said they couldn't see any productivity penalty really, I think, which is great, right? Because it means sort of you're not really paying a price to get all of these benefits, like you said, like memory safety, stability, right? Once it compiles, it actually like works most likely. Obviously, efficiency, right? Like orders of magnitude more efficient, in particular, than something like Python, Ruby, JavaScript, whatever. So I was really surprised by it, honestly. Like I thought there would be a productivity penalty, at least initially. But I mean, if that's not the case, then I think the question is what's holding people back from adopting Rust for everything, essentially, right?
Yeah, this is a very big, I think that's a very important question, and one that I personally struggle with a lot, because there's two reasons why I need to remember to be very careful when I talk about this. Because one, I sound like a crazy person. like Rust provides all of these benefits, and the evidence suggests, that other people can benefit from it too. So why not at least evaluate it? I don't think that Rust should be the choice for every single program or for every single problem. But if you are writing a large piece of software, more than 10,000 lines of code, Rust should be in the evaluation. It should be in the tools that you decide upon. At this point in time, we know that software increases in complexity. And as software becomes more complex, it becomes more brittle and becomes less safe for users. Memory safety provides security benefits. And I think that alone is important. But the real benefit is actually, to me, that Rust is a functional programming language in disguise. So the programming language theorists for many decades have said that functional languages are more robust. The stronger type systems provide the ability for you to create more reliable programs and so forth. And Rust has actually been able to provide that to programmers in a domain where they have previously only had tools that are sort of the opposite of functional. So Rust provides two quite famous types instead of exceptions. So an exception will be some error or some unexpected control flow that interrupts your program. In Rust, whenever we encounter an error or a function may return a result, let's say, or throw a result or throw an exception, we return this thing as called a result. And a result can either be the okay side or the error side. And the compiler will require that you consider both options when you call the function. So it is impossible to forget to deal with an exception. And the interesting thing from my point of view is that results type is not defined in the language itself. Instead, it is defined inside the standard library. The only thing that is defined in the standard library in the language, is the data type, which we call an enum, which is we've talked about enums and we might classify sort of different planets or something, and we assign names to integers. That's how people traditionally think of this data type enum. In Rust, an enum also can contain data. And so the compiler knows that whenever an enum so results are just enums. And like the magic comes not from the result, but from the type system. And every single time that you are dealing or interacting with some of these data structures, it just feels very empowering knowing that you can't make a mistake. Essentially, I can drive my car faster because I know that I can't hurt myself. Like you consider your own driving when you're playing a video game versus when you're in a real car. You're much more aggressive when it's safe. Yeah. And just going back to that blog post from Google, I am somewhat suspicious because I know that Google is, so there are a couple of people who have come back with some skepticism around, but I've a slightly different approach. And that is that Google, the person that wrote that blog post, or at least published it publicly, his name's Lars Bergstrom, I think. And he is the current chair of the Rust Foundation, I believe.
I mean, yeah, he's not completely objective on that topic.
But he's also true. Not objective inside Google. So he is from Android. And I think one of the messages, so it looks like it's a public blog, but actually I am somewhat convinced that his real audience or his real target is to convince people inside Google to adopt Rust.
I see it.
So, the real audience is actually people, so for Chrome is C++, but Rust is becoming a mainstream language very quickly. It is now inside the Linux kernel. It's now inside the Windows kernel. So we got these very large projects, and there are more and more large vendors or large companies that are investing very heavily in the language. What I would like to see is more, let's say, smaller companies using it. And I might be, if I'm building, I don't know, let's say that I am a microwave company, or I am selling anything that uses computers, and I might use C++, or I might even use Python. And those kinds of, I would like to see Rust being adopted more aggressively in the wider industry. The reason why these large companies, at least my analysis or my opinion about why these large companies have adopted Rust so strongly, is that it provides extreme performance and makes their systems much cheaper to run.
Yeah. I think in particular AWS sort of use it for that reason specifically, right?
Yeah, exactly. So the AWS or other hyperscalers, these cloud providers, the biggest bill, this was actually one of the reasons why I joined AWS, a company which I did not particularly like, but I had the possibility to influence the company and grow Rust internally and potentially save terawatts of power from being used in the world. That was one of the main motivating goals. And I think for smaller businesses, they say, "Oh, look, we don't have terawatts of power, so there's no use for us." Like this, and to that, I think that's a reasonable argument. My response though is, think about the frustration that you face when something breaks, or think about whether or not, if you use a JVM language, how it feels when the JVM starts to grow, and suddenly you start on like an instance with 8 gigabytes of RAM, and then it says that isn't performant enough, so we need to move to 16, and then 32, and now 64. And these larger instance types take very, very expensive to run, but also, and we think of just the one instance, but then we have development environments as well as like staging and testing and CI. And so all of them require significantly more resources. The effect is multiplied. And so therefore, my sense is that even if you aren't a hyperscaler, let's say, like even if you're not spending terawatts of power, you probably could save large amounts of money on your operational expenditure by looking at something like Rust. And it doesn't mean that you need to completely shift tomorrow to just completely have a new technology stack. Instead, I recommend that people gain some experience and learn a little bit about the ecosystem and whether or not it works for them, and to run experiments to try and validate claims that people like advocates like me make. All of these claims that it's going to be better for your teams, it's going to be better for you, you're going to feel like a more productive programmer, are just not meaningless, but they are claims that require context. And I know for me, as someone who, I came from a dynamic programming background, and I was not a professional computer scientist. I studied humanities at university. And for me, it's been completely liberating. But other people with different contexts and different history, maybe the circumstances will be different.
I think one other reason is also sort of we talked about this type system and so on, and sort of result type and how that makes things more stable and so on. I think another aspect relating to the type system is also sort of you can express so much in the types, right, that you can't express in the types in like whatever Ruby or Python, because there are no types even, right? But you can even express more than in Java or so, right? And I think that also has like has a very positive impact on long-term maintainability, right? Because you can much more confidently make changes, right? In particular on the web where you have like big, I don't know, JavaScript apps or big Ruby apps, right? Big Rails apps or whatever. Sort of you get to the point where there's so much sort of hidden rules that are not like expressed anywhere, right? You have to read through functions and so on, that sort of over time as the app grows, the team grows, and so on, nobody dares to make any changes, right? So it's like the entire code base is a big CSS file where you'd rather add stuff than change things because you never know what's going to happen, right? And like I think that is something that doesn't happen in Rust, right?
I hope it doesn't. So one of the things, like I wonder whether or not Rust is still too young. This will know to be able, if I have an application in production for, let's say, 5-10 years and multiple teams have worked on it, or there might be multiple, because a lot of people leave before 2 years. So after, say, 6, I've now had 3 generations of programmers who have worked on this thing. And each of them have slightly different opinions about the way that the software should be built. And so now it is just a giant mess. I think that you're right. I think that Rust is more stable, or at least it facilitates a more stronger platform, or it resists that. But I don't have the experience of running a Rust-based web app for several years, and so I think that the Rust ecosystem is still, I think we still need to gather evidence, but my suspicion is that you're very correct. One thing that about the type system, and one difference that, say, a Rust programmer might look at a problem versus a JavaScript programmer. Let's say that I was interpreting JSON, or so I'm calling out to an API and I'm interpreting the input. Now it's really common to just inspect the string. So the actual, whatever the JSON return value whatever came back. And I might I could store that in an object, or, pass it as a return, but my program, I'll hold on to that string. And then if I want to decide what to do with it, I would just always go in it. I will inspect the string. The problem is, so now I need to validate in multiple places because I might pass it somewhere else. And then that needs to validate that the data wasn't corrupted. In Rust, it's much more common to eliminate the string as fast as possible. So you receive the input and immediately parse some string. Let's say it might be like a category. Let's say it's a code for something, and so we validate that it's correct. And now we have like a product code, and now I have a product code type that has passed validation. And then in the insides of the Rust program, never has to deal with any of the data that has been provided by the API. Because if someone sends malicious data or something, or accidentally sends the wrong thing, that will never infect the internals of my system. And another, at least, so the mentality of a Rust programmer is to be more strict. And again, this comes back to the mentality that you can, if you force Rust to do things unsafely, you can continue to pass the string around. But the Rust mentality would be to essentially eliminate that as quickly as possible. Now, and it's encouraged with other parts of the language. And one other area that this is true, at least here's actually no. Here's one area that I am advocating for, like I believe should be true. I want to, and that is Boolean values should essentially not be stored as variables. So let's say I've got like is valid, and then I store this as like in some temporary variable, and 300 lines down in the program, I'm now checking some Boolean value, much more robust. And the problem is that when you refer to old Boolean values just in true or false, you lose the context of like what true means and what false means. And at least this is my experience. And I know that you're, clearly looking a bit skeptical. So this is not a universal opinion. But I believe that a much more robust thing to do is to return a type that describes what you intend. So essentially the documentation is the code. And so instead of returning like is valid true, I could return some enum that is valid. And so now I have and so the states could be valid and invalid. And it's essentially a Boolean, except the documentation is in the code. Like it's in the type system. It's in the error messages. It's impossible to misinterpret later. And again, it's very possible. You can write bad Rust code. It doesn't guarantee that your software is going to be completely robust. It's just, but it will bias you towards robustness, if that makes sense.
It relates to that thing that people say about Rust, where sort of learning Rust and using Rust makes you a better programmer, like overall in other languages as well, because of that change of mentality, right?
Yeah, I hope so. At least as long as people still talk to you, because you become insufferable, you become like this really difficult person who no longer is able to do things the normal way. I spent about 1.5 years as a Go programmer.
Yeah.
And while I was writing Rust in Action, actually, and they hated because I would always try to create types to represent error states, and they were like, no. And so because Go, for example, doesn't have constants, at least that was like not true constant. Actually, it doesn't have enums in the same way.
Yeah.
And it's just less strict as a language. And there are still, for example, nil pointers, bits of Go that I find very frustrating now as a Rust programmer. It's very easy to create. And I think that's one of the problems when we start to program in Rust. Suddenly everything else looks like it should be written in Rust.
It feels a bit, well, the popularity of Rust, and in particular, sort of from me maybe, who has done mostly web development, it seems sort of we're going back to where we came from in some way, right? Like in the 80s, 90s, whatever, you use C, C++ maybe to write web apps. I don't know, that's even before my time. But then after sort of there was like that notion of, okay, let's not have memory management, let's have garbage collection. And then sort of next step, let's not have types, let's do Ruby, Python, JavaScript, whatever. And now sort of we have memory management in a better way, or PHP, yeah. And we're going back to types because we see the benefits, right? So it seems sort of we're taking a U-turn in a way.
Dynamic languages in the Perl, Ruby, Python, JavaScript, and were on the fringe. They were on the outside for a long time, but they all emerged. Most of them emerged in the 90s. But by the time Ruby on Rails was created, they were dominant. So what happened there? Well, one of the things that happened is that the ergonomics, the developer experience became very important. The idea that we can ask the computer to do work for us. We don't need to do all of the work for the computer. Dynamic languages like JavaScript are easier to work with. There is less mental overhead, partially because of the type system is simpler. And so famously in Perl, you can, if you have a string that is an integer, you can actually use addition, and Perl will go and interpret it as a number, and it relates to like a whole bunch of other crazy, I think crazy weird bugs. But the sacrifice of robustness, we sacrifice performance, we sacrifice lots, but on the upside, we can feel more productive. We can essentially feel less constrained as programmers. And what I think has happened is that computing has become significantly more important, even more important than it was, let's say in 2005 or like pre-iPhone. Now it's impossible not to think about creating like a mobile app or, for example. But security and performance and maintainability are all very difficult problems. And maintainability in particular is very, very challenging. It's extremely hard to migrate and build new features on top of old systems. So that means that it's sort of impossible to know whether or not you have dealt with all the cases, because it's very difficult to deal, like, accept infinity.
Those languages sort of improve productivity, but I think they improve short-term productivity, right? And then long-term productivity, aka maintainability in a way, sort of that's not great then, right? And I think now where everybody has like 10, 15-year-old JavaScript, Rails apps, Python apps, whatever, sort of now you start to realize that, right? And that's also why, like, obviously you have TypeScript, or you have, I don't know, like type things in Python and in Ruby and so on, right? Because like in particular big companies, obviously, right? Like Microsoft created TypeScript. I think like Shopify is working on some strong typing for Ruby and so on. And I think all of these big companies, they realize they need types, right? Like obviously, like David Heinemeier Hansen and like 37 Signals with a small, like very senior team. For them, it works, right? But that's not representative of the wider industry, I think.
I agree, and I think that as soon as you reach a program size of tens of thousands of lines of code, you might have, again, multiple, the person that created the system is no longer at the company. Keeping things alive is really quite hard, because especially if you get stuck in an old dependency, like you've got an old dependency that is no longer maintained, and so you can't upgrade to the latest version, and then suddenly you have lots of trouble because the security updates you can't apply because that requires a new version of, I don't know, PHP, but you can't upgrade to PHP because the old thing. Anyway, now Rust does not solve the entire problem. It is just a programming language, but it does make some very strong steps forward. And one of the things that it enables is for you to define your dependencies. It actually requires you to depend on specific versions of a particular dependency. And the package manager itself, the cargo, relies on an index that does not allow you to, for example, to update the code of a specific version. So somewhat famously, the Python package index enabled maintainers to upgrade, essentially silently upgrade software packages.
Oh, really?
And so I could say I've released 1.0, or no, I've released, let's say, a minor patch, like, but I made a mistake. So in 0.15, I want to change. And so I just update that and just overwrite the old 0.15. And so now it's,
okay, didn't even know that.
I'm probably defaming the Python community, but my understanding is that is close to correct, at least. And there are other instances whereby the systems that we depend on in the open source world are less robust than we would like. And the other thing that Rust does, as well as require that your specific versions are defined, is that it requires, or at least enables you to what we call statically compile all of your dependencies into your application.
Mm-hmm.
Now, this is a somewhat complex topic. There are multiple sides, like everything in technology or in like humanity. We have multiple people on different sides of this argument. But whether or not this adds to security or not, I'm going to say it at least static compilation we should just define before I discuss its pros and cons. So static compilation is an approach to compiling where you take all of your dependent code and you compile it essentially into one place, and you ignore the system library. So the system, let's say we're deploying it to some Linux box. So we know that there might be a C compiler there, and it has a particular version of the C standard library, or there might be some other things that we can import with, if we run Ubuntu, we can just apt-get install whatever we want. And static compilation essentially ignores all of that and says, I am going to completely determine everything about my environment. And, and so I need nothing to run. Now, there are multiple disadvantages. It means that you essentially duplicate all of these libraries in every single application because they can't depend on one's shared source. Another thing is that if you do have a security vulnerability, you need to patch or you need to update all of your different software applications. Whereas in the shared library model, if you upgrade the shared dependency, the security benefits move into all of the specific applications. But one thing that Rust can enable is for you to you can expect that your executable will continue to run in 5 years' time because it just will run. It doesn't require anything from the environment. As long as Linux still exists, as long as you've compiled, or as long as Windows still exists, if you compile it to Windows or Mac OS, let's say, then your executable will continue to run. Now, will it be completely secure? Arguable. So those are two ways that Rust provide a meaningful step forward in terms of advantages for the industry.
I wanted to get back to one topic that I know is sort of important to both of us, and we briefly touched on it before, which is Rust efficiency, in particular as an energy efficiency, right? Because Rust runs on like fewer resources to do the same thing than, I don't know, like JavaScript, Ruby, Python, Java, everything else essentially. So that saves you money, but also means you use less energy, which has different benefits, right? In terms of sort of the greenest energy is the energy we don't use, right? I would be interested in hearing your thoughts on that.
One thing that is not obvious to people who don't build software is that most software is ridiculously inefficient. It's embarrassing how wasteful the software is. And I'm sure that others have a similar view, and I'm sure that there are people that have the opposite view. But the system that I am currently talking to you on has 32 gigabytes of RAM. It has a phenomenal processor that is capable of executing billions of instructions per second. I still find myself wanting more power. And this is because our applications are so hungry. The amount of power that we use, of there being microprocessors in every single device in our home, I wonder, probably very hard to count how many CPUs are actually in one house. The opportunity for Rust is to not just provide 5 or 10% of an increase, but reduce by 95% the amount of energy resources that we use. Now, and you think, well, how is that possible? Well, to run the equivalent program using, let's talk about Python. We've picked on Python a lot, but we could choose any of them. Let's choose Ruby now, and requires much more work from the computer. We talked about how in the 90s, there was a shift in our industry towards pushing more work to the computer. And that actually now requires up to 100 times more compute power to interpret and process. And and this is important because your large chips, the RAM also requires power. And like all of these transistors actually are, there's physics involved. And as like a network of societies, like humanity next 3 to 5 centuries are going to require a different attitude towards the planet's resources. Like I'm going to lose some friends here, but I just sort of don't care. Like, we are like a mass extinction event happening at the moment. I think that since the Industrial Revolution, we have exploited and extracted everything we can from this planet. Computing is not something that we can turn off. We can't say, sorry, can't use that anymore, but we can produce a future that is significantly better than what we currently do. And yes, it will save companies money, but hopefully it will also very significantly impact some of society's most significant problems. Technology is such a critical component every commercial enterprise in the entire world. Rust does provide a small glimpse of a possible future whereby we are actually aligned with the planet, and we can actually create a future that we're really proud of. At the moment, I don't think that there are too many people who are like, oh, I'm so excited for the world that we are creating for the next 10 centuries or the next 10 generations. Is Rust going to fix all of these problems? No, absolutely not. But I do think that Rust is an important part of a much, much larger story around like adjusting our perspective.
I remember like early 2000s or so, 2000, when Rails came out, and I got in lots of Rails and was great, like in many ways was a big change for the industry. And then I remember there were always these conversations about like, isn't Ruby too slow, right? Like, are you able to write a fast web backend and Ruby and so on? And the answer was always just buy a bigger server or more servers, right? It's gonna be fine. And I think while that was true, like it worked, right? I think that attitude isn't really something that works anymore, right? Like even I don't even know sort of what environmental impact sort of running a server for a year has, because that's also kind of like, I think that's part of the problem, right? Nobody really knows what impact the stuff that we do has on the environment. But it seems, even without knowing, sort of, it seems that attitude isn't sort of, or is obviously not sustainable, and not sort of, it's an attitude you can have at these times, right?
I mean, this is one of the downsides of thinking about computing as limitless. I know that cloud providers do care, but that does not mean that it is their sole responsibility. I think most of the electricity that is being generated in some parts of the world is primarily renewable, but there are other parts of the world, let's say Asia, where there's hardly any use of renewable energy resources. There is another argument against what I'm saying, which is that as people become more efficient with the use of some resource, historically what has happened is that the net use of that resource has actually increased rather than decreased. And so if we become extremely efficient at computing, so if, let's say everyone switched to Rust, we would not, as a society or as a network of societies, decide to shrink the annual compute budget, or we would just fill up the space with more work. And so that is one of the arguments against what I'm saying.
I think the answer to sort of climate change can't be, let's be like less efficient with our computing, use less or whatever, right? I think it's an interesting point for sure. Yeah. But yeah, do you think the efficiency and sort of like green computing aspect of Rust, do you think that should be part of the pitch, like when you and me and sort of our viewers sort of pitch Rust, or is it counterproductive?
The problem, well, I am always slightly shy about leading with the environmental aspects, and in my case, it's a perception that I want to avoid. If I'm talking to someone and then they suddenly say, well, look, I can ignore what Tim is saying because he's from some group that I don't agree with, so therefore I don't need to agree with Tim. Now, I don't know if that's accurate. Whenever I try to sort of pitch Rust, I always try to talk about it from like a self-interested point of view. just saying, well, actually, it's going to benefit you because you're going to enjoy programming in Rust. Fewer issues related to like downtime, for example, and your bill is going to be smaller, and et cetera, et cetera. And the environmental benefits always seem to be slightly more, they are sort of necessarily external to you. And so should it be part of the pitch? Well, probably. But one of the other points that you made was that it's actually very difficult to account for our environmental impact as people that are purchasing compute resources, especially compute resources from the cloud, because it's like it's very indirect. We don't know exactly the cost of the choices that we're making, and therefore in many senses we can't be completely responsible for them, for their for the impact, right? We're not responsible for provisioning the service. I would like Rust to mention environmental sustainability in addition to its other things. Technology people like to talk about the choices of technology that they make. They like to say that they are, in some sense, objective. We go through like a technical evaluation, and things like an environmental consideration will only have a very small weighting, if any weighting.
I think that makes sense. Yeah, I think the good thing is that sort of the environmental benefits are sort of like directly aligned with sort of financial benefits of efficiency and better performance and so on, right? I do agree it doesn't have to be sort of the main message we're sending.
Last night I was giving a presentation to people who were interested in Rust, but it was a local user group meeting, not for Rust in particular, but just a local meetup. And only, I'd say, less than a quarter of people had even used the Rust compiler. And so the technology industry here, I think, is several years behind a lot of more major technology areas, because we have there's a very strong conservatism with choosing technology stacks that have been well proven. And we have a couple of large businesses or large companies that were startups that have chosen, for example, C# and the .NET. It's a really fascinating discussion of how do you move people from being interested in a technology to actually going and really testing it. I think it's a very, very positive step for the industry as a whole. And but the benefits really need to be very specific and aligned to individuals, or essentially individual teams. And so having these kind of larger goals are, in some sense, I feel almost like a bit of a distraction, because when people listen to you and they hear you speak and they're like, oh, you love Rust, all of these goals are really, your passion comes through. And I do want to tell people that the people that are going to benefit the most are sort of you as the team that is actually implementing the product. By the way, your users are also going to have a wonderful time, because suddenly the application is more responsive. In particular with Rust, the tail latencies are going to be very, very good. One of the things about having what we've talked about before a few times is a garbage collector. A garbage collector requires time to do its work. And when your system is on a very, very heavy load, the garbage collector needs to take more time to do its work, because it has more garbage, or it has some more memory that it needs to decide upon to say, is this garbage or not? And if it is garbage, I need to get rid of it. That impacts performance at the tail latency. So about 1 in every 1,000 requests. And if you have a large microservice architecture, what you might find is that your users experience P9.99 more frequently than you would otherwise expect, because if they hit 5 services, well, suddenly it's actually much, much more frequent. They're actually generating 5 times the number of requests in some sense, a 1 in 1,000 request actually occurs more frequently.
What, in your experience, are the main concerns that companies have, right? When, I don't know, they might be convinced by the benefits, but there are concerns holding them back still from adopting Rust. And what can we all do, like you and us, to sort of address those concerns and like overcome them eventually?
It depends on the level of the organization. So in my experience, the developers are very, very enthusiastic for Rust. Typically, when a team considers Rust, there's been 1 or 2 people who have been learning it themselves and have been talking about it for a couple of years now, and they're excited. Senior leaders are also very, very enthusiastic because they listen to benefits like increased security, improved performance, decreased cost, and that all makes perfect sense. In the middle are engineering leaders or essentially middle management who are scared. And this fear comes from a couple of different perspectives. One, as soon as you introduce a new language into a technology stack, the whole system becomes significantly more complex. Suddenly the build system is more difficult. Suddenly we need to understand what a version means if our application is in multiple parts. And so this introduces some architectural complexity, which would not be present if there was just a single language. So adding a new language is always difficult. Now, specifically with Rust, there's a problem around recruitment. And the recruitment is on 2 sides. So there is constantly this concern that there aren't enough Rust developers in the world, while there are lots of people who are learning the language. Lots of people want to program in Rust, and there are lots of teams who want to hire Rust developers, but they're at a slightly different level. Like, let's say if you're a company who's evaluating Rust, the person that you want to bring on first is someone who's senior, who can exercise good judgment and who can guide the rest of the organization through a transition period, perhaps to Rust. But the people that are learning the language are less experienced usually, and they don't have commercial Rust experience. And so there's this very large disconnect. There is another problem on the side of the company, and that is, let's say that they were trying to hire a senior Rust person. They don't have the technical skills to evaluate that candidate because they are not Rust developers, let's say. And so they need to trust this expert. They're bringing in someone new because they have Rust knowledge, but they need to trust that Rust knowledge. And so this creates a problem for both from the recruitment process, but then also from an initial team's perspective. Like, let's say they do manage, let's say I'm a small company, I hire a senior Rust developer, and 9 months later, I have discovered that they are just creating their own little island inside my company. And that's now a very, very big problem because I've got this isolated part of code that I essentially have no ability to interact with. And so those are some of the major issues. Some of them, for example, this disconnect between the junior developers and the senior developers will just naturally over time will resolve. Eventually, things will reach an equilibrium. There is still a problem being able to give people confidence to evaluate and learn Rust. So I think it's mostly around a confidence problem inside these companies who are concerned that they don't have the expertise to create a Rust group, for example. So I think that some of the things that they can do is to essentially run experiments or create small utilities for their teams and try to use programs that are, like create small programs that their own teams use that are not customer facing. They don't require you to risk revenue, like your production system going down, and try to make sure that the knowledge is spread through the company, because you don't want one Rust group that is completely isolated from the rest of the team. Because as soon as you lose those one or two experienced people, the whole Rust project will fail. And once that fails, Rust will not be adopted for another 10 years in your company. And so it's a transformation for the business. Like, this is quite a scary, suddenly what seems like a technology decision is actually a much broader discussion about, for example, do we rely on more environmentally sustainable technology? How do we weigh up the security of our users versus our productivity of our developers? This will cause conflict, because if you have a large amount of knowledge in Java, let's say, or whatever other stack, there will be people who argue that Java is perfectly secure, et cetera, et cetera. So I think that the way to move forward on this is just to move quite cautiously, at least at first, to gain some confidence, to gain some experience, and to enable the technology to prove itself. Give Rust the chance to really demonstrate its own benefits, because once that has happened, it will continue to flourish. It will grow. It's very, very difficult, if you give it the right environment, for Rust adoption at a company to go badly, except when it becomes siloed. If you create this small group or small island of Rust expertise, and that knowledge is not shared, that becomes a significant risk.
Yeah, probably something that would give companies more confidence is, I guess, if there was more success stories, right? In particular for sort of smaller, mid-sized companies, not just AWS, Google, Microsoft, where sort of what they do doesn't really relate to my, 50 engineer team, right? But I think if you had more success stories from those smaller companies, right, I guess that would also sort of make it more...
One of the things that I'm very enthusiastic about, for example, are events like Eurorust, because Eurorust, it's local, it's not sponsored. Well, it's, it's slightly from the side, Main Matter is a large business itself, but to have more local stories and people that are relatable, rather than, for example, just being like lots of heroes from the Rust, very, very famous Rust people, and doing things. One of the things I quite like about Eurorust, or at least the video, what I saw from it last year, was that, it's like quite fun. There's like, the lighting is it's distinct and it's interesting and cool. It's actually not just the story. You need someone who's trustworthy, and there needs to be lots of small discussions, and rather than one, major thing, which is one of the reasons why, again, like, I like the smaller events, because what I mean by small is, compared to, say, like KubeCon, where it might be tens of thousands of people, like having a few hundred people in a room or in a venue is much more intimate. It's much more genuine, and I think that's really important.
Yeah, thanks for the Eurorust shout out. Are you going to be there, by the way? I know it's a very long way for you.
I would love to come. Look, and if I can make it, I will.
Yeah, it would be nice to see you there.
I've never been to Belgium. I would love to come. I really enjoy being in Europe.
Tim, it was very nice to talk to you today. Thanks again for coming. I hope I see you at Eurorust.
My pleasure. No, it's been a fantastic discussion. Hopefully there have been things that people have agreed with, things that people have agreed with less. And by all means, please start the conversation. So if you feel like interacting or, following up with any of the points that I've made, please feel free to say hello to me online. I'm very open to chatting about anything further.
Yeah, thanks again, Tim, and talk soon, maybe in Brussels.